Good afternoon, everyone, and welcome to our next session here. And this is exciting. I'm excited to have a great session. We're going to focus on how to use model context protocol to power agentic AI strategy. But before we get to that, and I introduce this amazing panel, I want to remind you that IIoT World has running its annual survey. And I think it's really exciting for building IIoT systems, our Internet of Things systems. And it takes only about a couple of minutes to complete. I think it's exciting. By participating, you'll help shape the key industry insights, and kind of once the report is complete, you'll receive free access to the results. And the link is highlighted in the chat for participants. So we appreciate you participating in that. So make sure that you do that, and that'll be exciting for them. So take the time to do that. So for those of you who don't know me, again, I'm Peggy Smedley, and I'm the host of the Peggy Smedley Show and the editorial director and president of Specialty Publishing and of Connected World. So thank you again for joining us. We have an amazing panel today. And I also want to thank Lucian and Carolina for letting me participate today, and all the sponsors. These are exciting sessions when we have an opportunity to get amazing guests and speakers who participate, who have amazing knowledge in this space. And this space is an exciting time that we're here today. So we're going to talk a lot about different things, but I'm going to start out by letting our guests introduce themselves. Now I'm going to hold them to a few minutes here so that we can get to serious questions. So I'm going to start with Boris. Why don't you introduce yourself, and then we'll go down the line, and then we're going to get to some tough questions.
Thank you, Peggy. And thanks for having me. My name is Boris Scharinger. I'm an innovation manager. I'm an AI strategist in the CTO office of Siemens Digital Industries. Siemens Digital Industries is the PLM and automation branch of Siemens. And my favorite topics are AI and how to make it industrial grade.
Aaron, you want to take it away?
Yeah, so great to be here. Thanks, Peggy. My name is Aaron Semley, so I'm Chief Technology Officer at HiByte. So my background was, came out of school back in 2008 and worked for a company called Kepware. That it's involved, if you're not familiar, is involved in industrial communications, so writing drivers to Siemens and control logics, and all the different devices, machines, getting data off of factory floors into HMIs, historians. That company was acquired by PTC, which was had also bought ThingWorx. So mid-career, I moved over to ThingWorx and was part of the whole industrial Internet of Things, trying to drive that to market. And now post that, joined HiByte, where we're focused on industrial data ops, so really trying to contextualize factory data and make that usable both in and out of the factory. And then MCP came along, and that's an obvious fit. AI agents and LLMs need contextualized data, external data, and we'll get into how MCP enables that. So happy to be part of the conversation today.
Thank you. And Colin, why don't you tell us a little bit about you?
Thank you very much, Peggy. Colin Paris, delighted to be here. I was the former Senior VP and CTO at GE Digital. I was an officer of the GE company, and so doing transformations with digital and AI technologies. Now I sit on public boards. I'm on 3 public boards in the insurance industry, banking industry, and the auto industry, doing the very same thing. It's an immensely interesting time to be in the world and being transformed using agentic AI and other things. Delighted to be here.
Well, thank you all. But before we get started, let's take a poll. Let's start our discussion off before then with a poll. So let's have everyone see and take this poll, and we'll start with that. And when we get there, we'll see what the results are in a minute, and then we'll see what happens there. And while we're waiting for the results to come up here, let's start with a second here, and I'll ask maybe the first question, and then they can give us the results here of the poll here. I would like to start, and maybe Aaron, you can help us. How is MCP, and maybe I'll ask the question, because we all know model context protocol is kind of groundbreaking. It's a standard, I think, when we think about Anthropic in 2024, and to solve a lot of pain points. And maybe you all can address this a little bit. But I guess for a lot of people who might not know, I think MCP is being used today, and what are some of the challenges around it? And I think, Aaron, maybe you want to kind of talk about it, because I wonder, when we think about AI integration, how large language models and real world data and tools maybe you have some thoughts on where we are with this.
Yeah. Some people feel like they're behind. I tell nobody in AI, everyone's behind, right? It's moving so fast. So you gotta be humble and just know that it's changing. So just learning about, just seeing the results now. So 70% just learning about it, 14% testing it out, and then 16% using it. So that seems about right. So it might help to just, for the folks that might not know a lot about it. You mentioned Anthropic back in 2024. So one of the foundations of MCP is this concept in LLMs, large language models, called function calling, that existed before MCP, right? So function calling, as we all know, LLMs are trained on data, and there's a cutoff date on the training. So that an LLM, a large language model, doesn't know the current weather, for example, right? But what they trained models to do is to say, if I ask an LLM, like ChatGPT, what's the weather today, it's trained to know that it can call a function to go grab that weather. So if you looked at that interaction, I as a user, hey, what's the weather today? The LLM comes back and says, it's not going to say this to me. It says it to the chatbot or the code that it's in. I don't know the weather, but I know you can call this function for me and get it, feed that answer back to me, and then I can process and respond to the user. So that's an interaction called function calling, and it's existed for a while. The challenge with every agent, and which an agent, I'm going to call an agent just code around a large language model. So think of it as it's the chat interface in ChatGPT. Everyone was rolling that themselves, right? So when the LLM came back and said, hey, go call this get weather function, I had to write code and then go call an API or some external interface to grab that data, bring it back into the LLM, and then it would have a response. MCP is a technology model context protocol, is a standard around that interaction, right? So then if I want to write a chatbot or an agent, I can support MCP, the protocol. MCP supports two really important things, both discovery of what we'll call tools. Conceptually, you can think of tools as like questions or interactions. So questions the LLM can ask and things that it wants you to do. And then it's a standard way to call tools. So I can feed into the large language model and say, these are all the external data sources or questions you can ask. And when you need that, I can write code that's standard to MCP that reaches out to any MCP server. So what MCP did is it really took that like custom coding everyone was doing to make function calling work, and it made it that, I can develop an MCP server, you can develop an MCP client, and now we kind of have a digital highway to get data in and out of LLMs. So that's kind of an important like basics to start, right? Like MCP is a protocol. Think of it as it's a way to get information in and out of LLMs. In terms of the challenges and where we're at today, you can think of it as like there's kind of a vendor run. I mean, we're all talking MCP, which is wild, right? It's wild to see news articles on a protocol, and I think we'll get into that. It's an important protocol because it's enabling LLMs, and it's important to understand. But what you're kind of seeing is a mad vendor rush into supporting MCP. So everyone's adding support because it is the way that you start to leverage the power or the promise of agents and LLMs in the future. It's how you get your product data, industrial data, which we'll get into these large language models and agents to start to experiment and find the value. So I think currently where we're at today, and you can see it in the poll, a lot of people are just kind of learning about it. A lot of people are starting to experiment with it. Like if I feed an agent this data from an industrial process, what does it do? What can it infer? So it's a lot of experimentation. And the challenges, I think we'll get into some of the challenges too. There's challenges around implementation of MCP tools. There's challenges around standardization of tooling. There's challenges around security. And I think we'll launch into get a little bit more in depth of some of those as the conversation goes today. But that's some of the background of MCP and where it's coming from.
So before we go any further, if any of you watching right now and listening have questions, please put them in the chat because these brilliant minds, I'm sure, would love to answer all of them, and we'll have time at the end. And I know, Boris, I'm going to have you answer perhaps our next question here, but you talked about the digital highway. When I listen to you, it sounds like that digital highway is pretty bumpy right now with all these vendors trying to come in at this race to the end here, or race to the start. I don't know, is it a finish line or wherever it's going to be? And so I guess when we think about all of this, when we think about the things that you're talking about, are we really talking about, despite all of its momentum, Boris, and this is what's coming to mind now, is MCP is still a very young standard. And with that, this race then comes to mind, where does it need to mature? If all these vendors are racing specifically for use in the industry, what do we need to be thinking about then, Boris? What do you think?
Yeah, that's a good question. And I do appreciate the momentum that we have around MCP because everyone is so excited that the ability to take application functionality and wrap it via MCP and make it available to an overarching AI that is then having the ability to orchestrate workflows and use those different pieces of business functionality, right? This is really a paradigm shift in how we do application integration or process integration and workflow integration. It adds so much flexibility to the kind of hard-coded way of how we did the API-based integration in the past, right? And Aaron, to your point, I'd like to put one additional thought here on the table, which is agents can be either AI agents or can be non-AI agents. Agents can be wrappers around classical functionality, in industrial applications. An agent can be a wrapper around a classical computational fluid dynamics simulation. So I'd like to see agentic AI as something that is being on top, using different types of agents. Some of them contain large language models and others do not contain large language models. And then MCP comes in really handy to integrate across all of these different pockets of business functionality, whether they are with AI or without AI. Now, if we go back a couple of years in how API-based integration worked out, right, and had matured, we could really see that, we had to bring up identity and access management standards into the way how we use APIs. And that took quite a while. We had to become clear what the protocols are. We had to, put API governance on top of it. We worked with things like, API discovery. And if I look at the recent June release of the MCP standard, it just added OAuth 2.0, right? The authentication protocol. It just now added the structures to provide structured responses in JSON, right? And this is just 3 months back when as the protocol has been extended. So this tells us a story about how young it really is. My impression is, if I may say so, that the adoption of MCP is really an adoption by enthusiastic developers in a sandbox environment almost, and the production readiness of it in enterprises, with topics like security monitoring, security event monitoring, maybe data leakage prevention mechanisms, hooking this into, corporate monitoring environments to understand what is actually happening, who is using what LLM to drain data out of which agent, and is this following the structures of authentication and authorization that we need in an enterprise environment. These are all topics that must mature, or each enterprise, each company will have to build their own structures, maybe using hybrid, like around it, to really make sure that it becomes a suitable, valid, and stable and robust enterprise platform.
That's a very important point that you raised there, and it leads us to many other questions. And I guess, Aaron, when we're thinking about all these different things, when we talk about why standards are created and to access data versus using existing standards, it's kind of a lot of push and a pull. And I think when I'm hearing Boris talk about this, there's many questions that have to be asked before new ones can be answered. Is that what we talk about when we're thinking about new standards and the importance of them?
Yeah, I think it's really fair for Boris to point out that it is a very new standard. I think when I personally, my story was I did the whole function calling, wrote my little agent to interact with industrial data, and shot a video back in November of 2024. 2 weeks later, MCP gets announced. At that point, I think I was still calling it MPC. Like I didn't switch I'm like, okay, MCP. And then I redid it in MCP, and I immediately saw the value as a developer of like, oh, if I just add MCP interfaces, I streamline a lot of what I just did.
Let me just quickly interrupt. That's the problem with acronyms. I'm just saying that's in general.
Okay, I'm glad I'm not alone. But yeah, to the point, like I had found a bug in one of the SDKs and submitted it through GitHub to try to help, and it was fixed that day. And coming from industrial, right, where I mean that's unheard of. Like we work on technology that's decades old. Like the fact that this thing was in motion. And to Boris's point, there was a new spec that was launched in June that had some stuff that is standard in API access. So it's moving fast, right? And so as an industry, we need to be nimble, and we also need to use it where it's most apt. I think the question of like a new standard, right? And like why one of the things developers hit immediately is they're like, well, why MCP? To Boris's point, we have APIs, we have all these other things. Why didn't we use those? And there was the real reason, the headline of that is that, and Boris pointed this out, like APIs are for coding, right? So as developers, we write we have this whole discipline of developing APIs that we can write code against. And MCP is for agents or LLMs, and there's a difference. And there was a blog post, I can find it. It was a while back, a simple blog post of a guy who wanted to get attached to an API that was like Carnival ride data. And what he wanted to do is expose that to an agent to try to figure out when the best time was to go to see his local Six Flags because the lines were down, right? It was a standard API for amusement parks. And what he did is, in a simple blog post, he exposed the API one-to-one with MCP. So all the tools, the API endpoints for MCP, and he gave it to the agent. And he did an analysis of what the agent did. And when you looked at it, it took forever to do the analysis. When you looked at what the agent was actually calling, what the agent was struggling with is, and this is common in APIs, is that instead of like a ride name that the API would take, it took a GUID or a number, a unique identifier. Because in code, we like things to be unique. So the start of this API was always to pass in the ride name and get the ID out, and then all the other calls to figure out what was the line for the ride, all this stuff, you had to use the ID. And the agent, in trying to do the analysis, would constantly mess up and throw the name in and not the ID. And when you look at the analysis, maybe it burned like 100,000 tokens, and it took 10 minutes or some amount of time to get through. So what he did is he put a simple MCP layer in that did a little bit of caching, so the LLM only had to know about names and didn't have to care about IDs. And he increased the efficiency by like an order, I think it was 2 orders of magnitude, right? It was much more efficient in its token use, and it hallucinated way less. It was a much more useful tool. So it showed that either A, we go and redesign all our APIs to be based on agents, and I don't think we're there today in terms of the problem. Maybe in the future that LLMs are the only thing that care about APIs, and we can do that. Or we put in this new layer called MCP that's a little higher level that removes the codiness of an API and allows the agent to interact with data more human-like, right? It's like another example would be if you book a hotel or an airplane or a plane ticket online. If you looked under the hood of the number of API calls you're making as you're kind of clicking through all the interfaces and it's probably on the orders of hundreds, right? But you don't want to expose those raw primitive APIs to an LLM because, like in the Carnival example, it's going to hallucinate, it's going to struggle, it's going to waste its time. So really, when you look at MCP and the origin of it, it's coming out of the sense that agentic AI and LLMs are more human-like, and they can't deal with these really low-level concepts of APIs. Because we as coders, when we develop APIs, we're trying to go as low level as possible so we don't duplicate functionality and all this stuff. Like we're trying to serve our own needs. And we didn't have this idea of agentic AI and LLMs when we were doing it. So I think that answers your question, Peggy. But that's why we have this new standard. So now we have MCP. To Boris's point, it's evolving fast, and it's not 100% there, but it's there enough today, and it's showing the trajectory that, yeah, this probably has enough momentum that it is going to be the standard to get data into LLMs and agents. And I think it has the legs to stay.
And it shows you, as you're talking about it, how fast everything's changing, and it's connecting to something else, which then leads me to this next question, which we all keep talking about how we're using like digital twins. So then I'm starting to think, how will this all then, it's all interconnected, and this is my mind. So when will like digital twins be combined with agentic AI through MCP, and what measurable business benefits? Because everybody talks about digital twins, and are we using it? So will manufacturers or service organizations expect to see it? I mean, are we looking at this? And do you see that happening, Colin? Is that making sense then?
Yeah, Peggy, it is. It is. I agree with Aaron and Boris entirely that we're at a new stage, but it's a new exciting stage, right? So when I think about what we're trying to do with agents, I try to simplify it. It's perceive the world reason about something, about some decision, then act, right? And here's where MCP becomes beautiful for me. So I've spent decades in digital twins, right? So the digital twin will give you a view of the world, right? I'll give you a great example before. So once I perceive that, what I love now is I have an LLM or an SLM that could give me a reasoning engine. How can I take that perception of the world and pass that as ground truth to that reasoning engine? And then that reasoning engine says, take an action. And MCP ties these pieces together. I can get that twin to talk to that ground truth, give that ground truth to an agent that uses an LLM as a brain. And then as a result of that, with some actions to do, I can hit some tools. A little example that we are now working on, if you look at some of the work in GE. So we have the usual gas turbine, right? What you find is a gas turbine is out there, it's running. All of a sudden, there's a temperature spike. Now, you could easily see that in a SCADA system. The SCADA system, it has a temperature spike. It can communicate through the MCP to the agent. The agent says, wow, look at that, there's a temperature spike. The agent now can use that LLM to say, go look up some historical logs. Is that a normal thing? What do you think about that? The agent then gets the historical log data, gives it to the digital twin. The twin says, given that historical data and what I see right now, I think we have a problem. We need to go replace a part. That same agent, can then go into the inventory system, and then from there we have it go and do a simple workflow to have a field tech go out there and do it. Now, this we have implemented as a very, I should say, a high-level pilot right now. And the reason why you could implement that in 3 months was MCP. MCP gave us the interface from the twin all the way to the LLM that we were using. We were using some open source ones, Llama and others. Now we can use ones that are with Microsoft. It gave us a connection to an ERP system for the inventory. It gave us connections to a ServiceNow system. So that use of MCP, to allow us to connect these things where I could perceive, I could reason, and then I could do something, that's amazing. That delivers value, because what happens if I do that and I get that done? That engine doesn't go down. I have more uptime. More uptime is business value. The minute I can point to business value in a couple of cases like that, I can backtread and I can say, make some investments in MCP. I need to get the security right, as Boris says. I need to get some of the latency issues right. As Aaron says, I don't need to have the best coders in the world do it. I can quickly put it together, see if it works. I think this is the power that MCP brings. That connectionism that gives us the ability to do this quite quickly and effectively from a financial point of view.
I love the momentum that you're talking about there, because anytime you talk about business value, that's what's exciting. Anytime you talk about uptime versus downtime, you're talking hundreds of thousands, millions of dollars, especially when you talk about a turbine going down. So Boris, can you expound on that? Can you talk more about how do you see this evolving around momentum that we're seeing from business value?
Well, first of all, MCP and the idea to connect very different pieces of business functionality to tie that together in what we could call a digital thread, Colin, right? That is an extremely high value proposition, because today we are using workflow management systems, we are using hard-coded API integration. We need a lot of support from system integrators that are expensive, unfortunately, and not just expensive when you do stuff in the first place, but expensive when you keep processes up to date and you need to change IT systems and do modifications and so on. So the value proposition is really high. And now MCP, I'm talking about MCP in a context of system integration as a system integration mechanism within the realms of one enterprise. But now imagine that those digital threads become possible maybe in a platform sense, right? In a platform sense that you have a multi-party, multi-agent environment, and then dynamically, as you request different pieces of application functionality from different providers, are pulled together in a dynamic way to solve your problem. Engineer me an airplane, and it will respond with 100 questions of how that airplane should look like, and then say, well, I can engineer you that airplane using different agents from different pieces of software. And I'm going to charge you $100 for it, because that are the incremental license costs of those features and those features of applications, all exposed to us via agents and via MCP as an integration mechanism. That is more or less, for example, the vision that Gartner sees, right? How applications are sold in the future. They are not sold as pieces of software any longer. They are broken down into pieces of functionality and then sold in the context of a digital thread. Now, I have a couple of question marks. I have 2 question marks, 2 fundamental ones on this vision. The first question mark is, if this is the case, won't we see a future then when the orchestration layer that I'm using, the LLM that I'm using to post my initial request as a user, right, as a business user, will that orchestration layer then do sourcing decisions for me? Will it expose me to its particular, in brackets, commercial preferences in what agent it is using to deliver what piece of functionality, assuming that for one piece of functionality, there are always several providers in the context of such a platform, right? And then we are very much in a Google search type world where, providers of content, of product, of web pages pay a fee to a search engine provider, in this case to an orchestrating LLM, to have their agent being featured most when a user asks an engineering question, right? Give me an electrical wiring diagram for, XYZ, right? And then Siemens pays, and then the Siemens piece of software is ranked above, and then the LLM will use it, and then the user will be charged in. And this would be a dynamic that I don't think would be appreciated by software providers. That is visionary, but that will turn B2B and the industrial space upside down, and I would immediately see a lot of reluctance by providers of industrial software to buy into this thinking and this type of dynamics, right? The second thing that worries me a bit, even in the example that you on a high level used, Colin, a couple of minutes ago, which is industry needs determinism and industry needs reproducibility more than anything else. So how dynamic can an LLM decide what agents to use in what sequence to solve a problem when I need to be absolutely sure that I can repeat and reproduce exactly that process with exactly the same agents, being exactly with the same pieces of data, because I have a regulator sitting next to me. I have FAA, I have the HIPAA stuff in healthcare, I have, energy regulators. And it is absolutely crucial that it becomes 100% reproducible of what my AI solution, my AI system has provided. And then if we look into this and say, okay, we need that degree of auditability, we need that degree of reproducibility, we may end up in hard coding workflows that originally would benefit a lot from the dynamic nature of what LLMs can actually do. Yeah, so these are my two cents. I don't know what you think, Colin. And
I don't know if Aaron or Colin want to address that or not. I don't want to put either one, but it's an interesting. You raised two very interesting points.
I think those are some great points by Boris. Let me talk about the second one first. This notion of reproducibility. So what we have learned to do is whenever we use LLMs, you have a RAG capability, right? And so RAG allows me to determine exactly what sources of data the LLM used. So what we've learned to do, every time we have LLM do reasoning, it actually does an audit log that says, I looked at this manual and at this line, and I looked at this manual and this line. So it actually gives you the chain of events it did and the chain of reasoning it did based upon the manuals we have. And then what we have learned in the past is that we then take that and we compare it to what we see some of our field techs do, right? And what you want there for the level of determinism is that you arrive at something similar based upon the data that was given. And the bizarre thing is that in quite a few cases, the LLMs do the right thing more than the field tech. Because what the field tech will do sometimes, the field tech either hadn't read a new log entry that came in that says we're doing this, or the field tech says, well, I think these parts from this type of supplier are better parts than this type. So we've actually seen the reverse. In some sense, if you use RAG and if you have that auditability, you can make sure you're conforming to certain things. And again, these judgments are limited to things like part selection, the series of steps you do in the workflow to fix something. Once you keep it to that, I think that's when you get a certain level of determinism within the bounds you've given it. Now, if you go to design, it could be very different because there could be many different things. So I think for a lot of us, the idea is that determinism is coming out of the data we've written manuals. We have certain instruction sets we run. There's certain configurations we demand that you stay together. And the LLMs seem to actually, they can actually cope with the spread of that and actually fit within that bounds. So I think what we'll have to do is we'll have to figure out which things can be applied in that capability so that we feel comfortable. We as the chief engineers, who take this, and then we'll do the usual things. We're going to run a few of these things, test a few of these things. The thing I always think about is that we did a study at one point in time, and I won't say the exact study, but it was amazing. Our field tech folks were right 75, 80% of the time. They aren't perfect, but we always expect the LLMs to come to perfection.
Yes.
So we'll have to find that little balance to get.
That's an excellent point. Yes. Yeah.
So looking at this, and I guess there's a lot of moving parts that you talk when you talk about determinism and the change for reasoning. But I guess that means, Aaron, if I'm thinking about the things that both Boris and Colin are saying, I hear that all MCP tools are not the same. Or if I look at open standards, are they just, anybody can do it then? Or if we look, what the future then for the design of all of this, because we're looking at agentic AI, we're looking at all these LLMs. It sounds like there's a lot of moving parts, and trying to piece it all together might be a bit challenging, yet a lot of opportunities for how agile the market is.
Yeah, it's really, and the determinism question is a really interesting one too. And I think Colin's example is really good. And then as engineers, to his point, like I view LLMs as a tool, right? Like we as engineers are trying to figure out where can we apply that tool reliably enough to be useful, right? So to that point, like if I look to the future of architecture and what this looks like, I think there is this emergence of an agentic platform, which I think is part of what Colin's talking about. And that layer of the stack is really, I need to manage agents, multiple agents, the LLMs that they're accessing, the tools they have access to, and kind of orchestrating. And really important, what Colin brought up, is auditing what they did, right? like what did you do and when? And to me, that's an emerging market that's forming now. And you could look at a few different players. The big cloud providers are obviously interested in that. Whether or not they'll be like industrial focused agentic platforms or they'll be broader than that, I don't know. And then below that, we're in the data ops space. So we think of that like contextualization layer specific to industrial in the factory, and how we expose contextualized data, which the LLMs need, through tools, right? And also on the side, so you think of agentic platforms and data ops. In the data ops space, we're responsible for security around the tool access, making sure that these agents aren't going to make calls that like delete entire MES databases or whatever, right? We want to put guardrails around the tooling they have access to and what these things can do, and also audit, what tools, what data the agent is accessing. Where that becomes really important on the determinism side is what we see in the agentic platform is today, a lot of what you see in terms of proof of concepts and what people are doing is they have really generic tools. And Colin, this probably is not the case with you, but like it has access to a large swath of maybe the ERP system, historian, industrial data. And we're doing experimentation to say, okay, if we give it access to all this information with various tools, what can the agent do? in order to make agents more reliable, if we look on the IT side, what they're doing, they're scoping things down, right? So what they're doing, like the example that Colin had mentioned, and this is probably how they've implemented it, but instead of having one agent that's trying to do all those tasks, you actually have maybe half a dozen agents, one that's looking at the real-time temperature sensor, one that's connected to the maintenance system and knows that world, right? And the reason we have to do that is because we're trying to control the hallucination of LLMs. And really simply, when you look at these models, we're feeding, this makes me laugh, but we're feeding a text document into a neural network and getting some interesting output. And the only real lever we have is what's in that text document, right? That's prompt engineering, what we're trying to do. So what we do is if that text document gets too large, and we've all had this experience in ChatGPT, like just open new window, start again, like it's off the rails, we have to start again. So if we limit the context to what gets in that window and we split it up and we focus these agents on smaller tasks, we get more reliability, right? And that's what the Agentic platform is doing. On the tooling side, that also means today we're starting out with these like really broad swath tools. And I've seen, this is bad, do it in development, don't do it in production. But here's a tool that exposes my entire SQL database that is my MES, and I just allow the agent to go wild. That's great until the agent drops all your tables, right? Bad idea. What's a better idea is I'm going to expose like just certain information contextualized for the agent. And that's really tool design. So tool design is really important. I think over time, you're going to see tools get more focused on particular data to control that context that the agent is running off of. Like, I just need the live stream of the sensor data, or I just need a swath of the last 5 minutes of historical data. Give me tools that are really simple just to access that information. And then I also think over time, and this is farther in the future, I think you're going to see models trained in certain domains on certain tool sets, and you're going to see those MCP tool sets standardized. I can't point to anything in industry that's doing that yet. We're working with Sesame on this standard API standard called i3x, and we're starting to look at MCP there too. So that's one example of maybe, and we're probably still 6 months to a year out from releasing that. But I think you are going to see hyper-focused, standardized tool sets that models are trained on, again, to increase determinism in the future.
So going on what you're saying is the tools, and Colin or Boris, if you wanted to chime in on this, you're saying we're really having to look at this data very carefully and narrow in, because if we don't, we're going to see a lot of, I don't want to say bad data, but the data's gone wild. I just want to say that's the way you described it. So you have to look at it very closely and maybe narrow in very specifically to get the right, I don't want to say decision, but really be very specific to get to that right operation that you're trying to achieve.
Yeah, and like really concretely, if I expose a time series historian with historical data to an LLM, and one tool provides the data with a timestamp that's in a certain format, and then you go to the next system and it's a similar query, but the timestamp's in a different format, that's opportunity for the LLM to not understand the data. Versus if I can standardize just the timestamp back, I can get better performance out of the LLM. So it comes down to this, like really trying to control both the questions the LLM can ask and the format in which the data is passed back can really optimize reliability, which is one of our biggest challenges with large language models.
So continuing on, and anything going on with this, and Colin, do you have thoughts then when we think about an MCP as a technical protocol for connecting AI to tools, based on what you're hearing Aaron kind of talk about right here, and how can there be a practical experience? Let's go back to it being complex. We'll go back to the digital twins and agentic, because I think when I heard you talk, I'm still going back to that turbine example, but is AI shaping the evolution of, what we're doing with an MC standard, those outcomes? I just think about the lost revenue or the time, or really business outcomes to what I heard you say, and the idea of saying how the uptime is so critical in all of this. And I see digital twins being critical, but I also see now, listening to what Aaron just said, you have to have good data to make sure you're achieving those objectives.
Peggy, I very much agree with that. I think without the data, everything else is just a joke, because that has got to be the core of it. And I love what Aaron said. Let me give you a perspective on that. So he's quite right. If I have that data coming in and I have timestamps that are different, and I expose that to an LLM through MCP, you can have a number of things. So one of the approaches we think about is maybe build upon a foundation that's already there. So if you look in the industrial world, we have something called OPC-UA, the Open Platform Communication Unified Architecture. So that's a standard that was started, I think it came out in 2004. By 2008, they had a platform. 2010, we began using it everywhere. What that has, to simplify it for the rest of the audience, it has two things. It has the data and the context. So one part of it will say the data is 25 degrees Celsius. Then the context part will say that's the data valve 4, that's the temperature of valve 4 in turbine 3. So I have the data and the context, right? And then I can say what time it was taken, because these are all time series, and I can give you latitude and longitude if you so wish. The good thing about that is if you build on top of that standard, you put MCP on top of that. What you now have is the ability to align something that's giving you the ability to talk to agents, but you're on top of a standard that has already cemented the context, with a number of things. Because OPC-UA uses machines on the shop floor, it uses devices out in the field, it uses software we run against, it even ties into clouds. So that combination of using MCP in that context gives you a measure of protection in some sense, whereby you know that you're standardized the data that's coming in. The reason I think you go back to the twins is because if you go back to business value, if you look at the things that matter in certain worlds, whether it be uptime, be throughput, it be latency, it would be accuracy, you can say there are certain things that I need that are highly valuable. If I have a problem that's worth $50 million, I can bet you I'm going to focus right now and build proprietary things. If MCP shows up and says, rather than spend $1 on proprietary, I'm going to combine these things. Already Microsoft has a version of OPC-UA, and they're putting MCP, their version of MCP on it in a draft proposal. If they already have that and they're connected to my data sources, I'm going to say, let me double down on that. If there are other tools that, again, go after that OPC-UA MCP standard and combine it together, I'm going to double down on that. So again, this notion of starting with the business that we want to go after. Now, I don't want to stop the different types of technological creativity, but if I start with the business and I go backwards through it and understand what the KPIs are, then understand where I would go after, especially in industries that are growing, right? You find a way to tie it together. For instance, I spent time in the grid space. We know to feed these massive LLMs and everything else out there for AI, we will need 3x what's on the grid. So you need 3x the number of people working inside these utilities. You can't get that. So you're going to have to find a way to use AI to do that in some form or fashion. So we're going to have to standardize on things that already exist. We're going to have to listen to what Boris said about the fact that it had better be deterministic, right? It had better be safe. But I think the way to do it is to go backwards from the problem all the way through using the standards we already have and have MCP layer on this. And I love the fact that MCP has been adopted rapidly. And they're big players, Microsoft, it's Amazon, it's all the big LLMs, Anthropic led the charge. All of them are trying to get it to a certain point. If we could get a couple of the right use cases, I think this is the way you drive it. Because I'm going to embed this into systems that control the world, and it has to be right. So I think this is the way you look at the twin, and that twin then helps drive MCP in the right direction for it to be useful for a lot of us very quickly.
Very good point. Very good point. I think we can talk about the shift in talent shortly, but I thought maybe we could shift gears a little bit and maybe take a question. We've got questions already, so I thought maybe we'll do it. So let me read the first question here. It says, the Model Context Protocol, MCP, addresses the critical challenge of legacy system integration by providing a standardized client-server model for an AI agent to access siloed data from shop floor systems like MES, manufacturing execution systems, ERP, enterprise resource planning, and PLM. Somebody loves alphabet soup here, acronym soup, so I'm just throwing that out here. Does MCP is a better options to unified namespace data mesh? What is the evolving architecture to deploy MCP for industrial AI cases? What are the barriers manufacturing face to adopt MCP? Wow, that's a lot of question there. Who's brave to take it?
I could take a quick stab at it. I mean, one of the challenges immediately is the use of LLMs on manufacturing data, right? So there's security concerns around taking production data and using that in online, open AI, for example. So that, internally that can be a challenge. There's a lot of, like Colin had mentioned, small language models that come a long way, right? So, I think the future is running some of these workloads, a lot of these workloads locally on your own LLMs. Aside from that, I think you are seeing a mad rush of vendors adding MCP support. That MCP support is typically, like Colin mentioned, OPC-UA, which is an open standard, but a lot of times it's not, right? It's like custom, depending on how they store the data, how they contextualize the data. So I think there is risk of folks jumping in and connecting in with vendor-specific MCP implementations and not really owning their tools. And the challenge there is if I get an agent working in Factory 1 that's on tool set X, MCP protocol and tooling, and then I go over to Factory 2 and try to get that agent, and it's a totally different technology stack, which we have across all our factories, very heterogeneous environments, you're not going to be able to replicate the business value of the agent, right? So what we try to do in the data ops layer is we try to send the message of right now, because there's not a lot of open standards, you need to actually own your tool design for specific use cases such that you can replicate those tools across factories. And to Colin's point, when you get value in an agent, you can then replicate that business value across factories with the agent, because you say, I'll bring my tools, I'll wire them into the specifics of my factory, wherever this data is coming from. But from the agent's perspective, it's the same tools, it's the same data, I'll get the same outcome. So I think that's one of the challenges architecturally that's not so apparent. I think over time, like I said, you're going to see standards emerge, LLMs trained on certain models, and that'll be less of a concern. But right now it is sort of the Wild West of MCP. The other thing is you want to think of MCP, and there's categories of tools, right? This is just like how we use agents to make our lives easier. So the one we're talking about is industrial data. So how do we use it in industrial practice? There's tools for configuration of product. How do I make, and we use these, like how do I develop PowerPoints a lot faster? You can look at industrial systems and say, how do I go in and deploy all these tag definitions, or how do I deploy these ETL or pipelines or modeling contexts and use LLMs with MCP tools specific to product configuration. And the last one I would say is just troubleshooting. So how, when I come into a factory system, is there tooling that exists for me, like what's going on? Why is data not flowing? And it can come back and answer those questions. So there's like different categories of tools. I think the industrial ones, the data ones that we're talking about are probably the most interesting right now, but know that that's not going to be it. I mean, this is basically how you apply LLMs to the entire spectrum of what we do in factories and with industrial data to make our lives more efficient.
Can I add one comment onto that? One concrete example, right? We are extremely successful with what we call a co-pilot for engineering, which helps automation engineers to generate PLC code, but not just PLC code, but all sorts of different artifacts around it, documentation, test cases, and so on, right? It's wonderful. Now we are using OpenAI's models, leveraging the Microsoft Azure environment. However, I can tell you that OpenAI, including Microsoft, they change the weights of their models overnight. And they are not following ITIL best practices. They don't send us a change note before that, right? They do it all the time, right? So you are confronted with a bunch of automation engineers, and they develop their prompts. And overnight, using the same prompt, they get a different output, because the model weights changed overnight, right? So this is an example how LLM technology is the opposite of what I call industrial grade. So we had to implement 1,500 test cases that we run each night to make absolutely sure that the most important elements of prompts leading to PLC code being generated stay stable. So we do each morning a deviation analysis, and then we change and adjust the system prompt to kind of make these effects of the model changes, to roll them back, so the automation engineers wouldn't be confronted with those changes overnight. In other words, making AI industrial grade, specifically LLMs, is tough. And by the way, we believe in a good combination of LLM technology and knowledge graph technology, because knowledge graph technology is really one way to particularly bring in determinism and rules into what LLMs do, right? So all of that needs to be put into consideration. And this is not an MCP protocol question. This is an how can we use non-deterministic technology in a pretty deterministic environment like industry?
So that raises a lot of questions, and it's probably a good one here for our next question that came up. When you think about an MCP server or a downstream APIs might implement, and this was the question, important security controls like rate limiting or request validation or traffic monitoring that depend on the taken audience or credential constraints. You know, we take it a little further here, but if clients can obtain and use tokens directly with the downstream APIs without the MCP server validating them or properly or ensuring that the tokens are issued for the right service, they bypass these controls, etc. There are several risks listed, or should this be a priority? How secure is it to use it? You know, it kind of takes into another consideration based on what you're saying as well, Boris. What are things that should be addressed there?
Well, the question is spot on, and this is why I believe MCP in many cases is, you know, a sandbox technology that is really adopted by developers. But, you know, how much of these solutions really made it into the production environment of a mission critical industrial process? So all of these topics are spot on and are flaws and gaps, and the only way that you can solve them is now by developing an overarching own and architecture, right? Or use commercial sparring partners like maybe HiByte that help you addressing those challenges, you know, because you need to have a lot of things surrounding MCP and surrounding your AI system architecture for the reasons of governance. So, you know, when the protocol doesn't help you, you need to build the tools around it. And there are some commercially available or some on the horizon becoming commercially available. And until that, you know, don't use it for a nuclear power plant.
Anybody want to add to that?
No, I very much agree with what Boris just said. I think that's spot on. But you know, but I think this is the call to arms, because I think you have a lot of issues with governance, auditability, you know, security, cyber. There's a number of things that need to be built around this capability. But I think we need to really lay that out and decide how quickly we want to do that. See, the challenge I think we face is we move into a more and more complex world, right? And in the complex world, we have several things. You know, they say things like you can't predict the future. Well, I'll make a couple of predictions to show you that's not true. For instance, Colin will go old. You know, that's an easy prediction. That's going to happen. We have machines that are going to degrade. We have people who don't want to pay higher prices. We have complexity with the weather systems that we have in the world. We're going to come into more and more complex situations where we're going to have to deal with it. And so we need the best tools to come forward, and we don't have the time we had before. So if I look at the growth of LLM capability over the last 3-4 years, it's been amazing. Do I think we need more of that? Yes, we do. And I think the ideas Boris had, you add that to a knowledge graph, you actually have guardrails on that, you put MCP to join these things, you build tools around it. I think you have to build out these ecosystems. We're at a point in time in which we can't stop progress right now. We have to actually find ways to understand what the issues are and then go do those. Because we really have some issues on the planet in which we need to use some of that extra capability. The complexity of the problems we're facing right now are things in which we will need to expand these things. So let's line out what the problems are, then let's go at them very hard. I'm hoping HiByte actually lays out what their roadmap is and we move ahead, you know, and then I could go buy some of that.
Yeah, and I would only add that like human in the loop is still, I think, really important with a lot of workflows, right? So like to Colin's point, like we're going to get to the point where we're going to create a work order to go work on this equipment, but we're probably going to pass that through a human before that goes into the maintenance system to say, hey, is this good or bad? Like, you know, I'm a software developer. Would I walk away for a week and let Claude Code just go wild on our code base and expect to come back in a week and have it like it did well? No, I wouldn't put it in autonomous mode. But can I use it to drive my efficiency with me in the loop to say, yes, that was good. No, that wasn't. Yeah, I get efficiency. I think the same applies for manufacturing. So I think some people look at it and go, we want to totally autonomize workflows. To Boris's point, in a nuclear power plant, probably not a good idea. But can I leverage this tool to increase the efficiency of my workforce by exposing industrial data through MCP to LLMs? Yes, you can, right? With a human in the loop. So I think until we figure out more broadly the determinism problem, we don't want to be using this for completely automated tasks. I call it the, every nth iteration, you're going to get a random cat meme and you have to design around these things to be able to handle that, right? But does that mean that they're not useful and they can't drive value for the business today? Absolutely not, right? If I can inform an operator with voice to text, give them some ideation around why the machine isn't performing, it doesn't require them to go into like 15 different screens and bring up software while they're running around the factory trying to get something done. If I can ideate with them using industrial data through MCP with an LLM, there's a lot of value there, right?
So final thoughts. We're running short on time here. Would each of you like to give final thoughts on where the state of MCP? Boris, you want to go? And we've got a final poll here in the meantime.
Yes, sorry, the poll was coming in while I was still muted.
Yeah, well, sorry about that. They want you to rate the session while they're doing that, and you can give your final thoughts.
Exactly. I'm really excited about the ease of system integration that MCP adds, right? Specifically in the context of AI and agentic workflows. We are very early. It's going to mature, and it's going to mature because there's so much momentum behind it. And that's why I'm really excited about what's coming.
Aaron?
Yeah, I'm excited to see the rise of that agentic platform layer for industrial and what that means in terms of the business value, and then excited to fuel that from the data ops space with contextualizing the factory data to make it usable by those platforms. So, and I think MCP has enough legs now that I would be really surprised if it's not around for the long term. I think it's got so much momentum, and I'm happy to be part of it and try to help it harden it for manufacturing.
And Colin, final thoughts?
Yeah, I'm a big MCP fan. In fact, I made a suggestion that why don't we use some LLMs to actually accelerate MCP, right? Especially for industrial uses, right? If we want to live it, let's live it the right way. I do take what everyone said as true. We have to be very cautious as we do things. I love the human in the loop. I love everything that was said, but I think we've got to go full guns ahead. There are just some tough problems on the planet that we need to face, and I think this is a powerful tool for us to use.
Yes, I agree with you. I enjoyed this panel. You are all amazing people. I want to thank you as being your moderator, and thank you for allowing me to do it. I want to thank the sponsors for being a part of this. And I want to remind everybody to take the survey because it's really important for IIoT world that you take this survey. So please do that and complete it. It's right there. And again, thank you all for letting me be a part of this. I've enjoyed it, and thank you, and have a wonderful afternoon.